So good morning to everyone. Good morning all for joining to this FDP on data sciences. As a custom to inaugurate the session, I wish to start with the Vidya Mantra to seek blessings of Ma Saraswati. Saraswati Namustubhyam Varde Kam Rupani Vidyarambam Karishyami Siddhir Bhavtume Sadha means salutation to Goddess Saraswati, the one who has given boon and grants wishes. As I begin my learning, shower me with the knowledge and the intellect to attain the needed wisdom. With these words of seeking blessings of the Goddess of knowledge, I wish everyone connected to us today a very good morning and a warm welcome to all the participants from different geographical locations of India. MIET Institute of Engineering and Technology has started the series of the second Faculty Development Program on Data Sciences, organized by the Department of Information Technology. The FDP is commencing today and will continue till 5th December 2020. The dignitaries connected to us, the participants who include the academicians, the research scholars, warm welcome once again to all of you. While the pandemic still continues to disrupt normal operation, we are fortunate that AICT continues to maintain the normalcy as much as possible through the scheme of AICT Training and Learning Academy. The main objective of ATAL is to support technical institutions in fostering research innovation and entrepreneurship through training, to stress upon empowering technical teachers and technicians using ICT, to provide a variety of opportunities for training and exchange of experiences such as workshops, orientations, learning communities, peer mentoring, and through FTPs. Once again, I'd like to thank AICT for connecting all the academicians, industry experts to this or through this particular faculty development program. Data science, an interdisciplinary field, uses scientific methods, processes, algorithms, and systems to discover knowledge and insight from corpus data available, which is both structured and unstructured. The main objective of this FDP on data sciences is to deliver knowledge and provide hands-on training to the participants related to the fundamentals of data sciences, its applications, and techniques. Different domains like coding, statistics, mathematics, machine learning, deep learning, data analysis, visualization, and big data will be explored in this particular FDP. This FDP will provide a vast exposure and platform for the faculty members and research scholars to opt the field of data processing and analysis as their research domain. With this objective, I welcome once again to the newly connected participants to this FDP. We are fortunate to have our Dean Academics, Professor Dr. D.K. Sharma, to be the part of this faculty development program during the inaugural session. I request D.K. Sharma sir to please share the words of wisdom with us and with the participants connected.
Very good morning, one and all present here. I welcome speakers on behalf of MIET group of institutions. I congratulate Dr. Nidhi Tyagi and her team for organizing this FDP program. In this program, definitely the knowledge sharing, advanced information sharing, technology sharing will guide and help participants to enhance their capabilities and knowledge level. I hope this FDP will reach a grand success. Thank you. Thank you once again.
Thank you, sir, for your blessing words. And we hope this FDP will be a success. And by the end of this FDP, we will be having number of participants who will be involving themselves in the field of data sciences. I welcome Mr. Anshuman Tyagi from Edmonton, Canada, who will be the speaker for the first session. To give a brief introduction of Mr. Anshuman Tyagi, he is presently a co-founder and director at Kuwait Verdict Consulting Incorporated, having over 25 years of varied experience in software, IT business analysis, support, design and development, data analysis, data warehousing, ETL, in different roles from business analyst, software engineer, technical analyst, team leader, and architect. He has participated in and led more than 50 software development and support projects. He has an experience in producing a variety of documents such as business plans, business cases, strategies, project plans, business, functional and non-functional requirements, and many more. He has worked in various companies as Natural Resources Canada, Ottawa, Nortel Networks, Ottawa, and many others. He has patent to his name titled Auto Discovery and Management of Base Station Neighbor in Wireless Networks, a US patent which was accomplished in 2014. Number of research publications are also added to his career. I welcome you, sir, and invite you to have a first session of this FTP on the topic Data Science Overview and Architecture of a Data Collection Application.
Thank you, Professor Nidhi, for the warm introduction. I will share my slides and then we'll start with the presentation. As you mentioned, I will share first. I don't have permission to present now, share my slides. Can you give permissions?
Sure, sir. Maybe now you can access the...
Yeah, I can do now. So, just want to confirm, can everybody see my screens?
Presently, so it is not visible.
Can you see now?
No, sir.
Okay, let me check again.
Yeah, it is now presenting.
Okay, it was my
Thank you.
mistake. I was not, I didn't click on share and I was thinking that I have. Okay, so as you mentioned, first of all, thanks for inviting me to give an overview of data science. And this is a topic I'm really passionate about, though I've worked in very different areas like telecommunication, then web application development, and so on. But in all of them, data analysis was always a core piece. So from data analysis came data science. So I've been very passionate about it. Then as during my bachelor's, when I did my bachelor of engineering, I remember taking a number of mathematical related courses that were part of my degree in computer science and technology. And these included like matrices, statistics, numerical analysis, discrete mathematics, and all that knowledge which was gained, I've used it in like doing my master thesis in for a mathematical model, doing a mathematical modeling or network topology, and now recently, last 10 years, I realized that how important that base was for me to use it for data analysis and data sciences. And so as you will see during this presentation, there are certain core things which we need to know, like computer science, all those things. But beside that, we need to have statistics as well as mathematics, like skills, or at least the knowledge or the intuition why it is the way, why we are using certain API and all those things. So we should have those intuitions. So that's why I will present those. And from there, it will be like my goal is that during this presentation, you will get I'll be able to raise your interest in this topic, and you will have better understanding of data science, what it is. So let's start with the outline. This it's a very simple outline. Why data science? The reason for data science as a field. What is the need of it? So then why, after why is answer, we'll say what is data science, and we'll say how did data science came into being, like the timeline, how it started, and as with everything, there's a gradual change, and it's like evolved, how it evolved, we'll talk about it. And then we'll talk about data science life cycle, how the data it changes from, like we capture the data, we maintain the data, and all those things. We'll talk about that thing. And following that, we'll talk about the skills which are required used in data science. Follow that, we'll do what data scientists do. Like in academics, we talk about data scientists in a certain way, but in reality, still, data scientists are really involved more in data collection and then data presentation, visualization, and all those things. We are still not at the stage where we are talking about like 20% maybe talking about advanced machine learning kind of functionality, but most of us are really still in the preliminary stage of data sciences in the industry. So I will present an architecture of a data collection application which has been developed where I'm working and we are using it. Then we'll have conclusion, which just provide a summary of what we learned in this presentation. And then followed by, if time permits, we'll have some Q&A. So let's start with why data science. So we'll talk in this how data science has gained popularity in the last decade, and what are the factors and what are the characteristics of the data which requires data science, which makes data science to be critical. So we'll talk about with the data first. So it's the data growth which has really is the main driver for data sciences. Like data has always been there to make decisions. In many cases, people with formal education like MBAs were really there, who go to, like they've done undergrad in like engineering or some other area like medical and all those things, and healthcare and all, and then they decide, okay, do MBA. And in MBA they learn about like all the various topics, finance, HR, accounting, and they are also taught about business decision modeling kind of courses where they are able, which is similar concept of data sciences, but not the tools which are used for data sciences. So there it was used, MBAs were using business decision modeling tools. Similarly, there was Six Sigma methodology, which was also based on data, which was used, which is still used for process improvements. But it is again analyzing the data to come up with improvements to the process. So it was there, that means data was always there, but now we are talking about data sciences. So it's basically, it's just that there's too much of data to analyze, and those traditional ways we were doing and those people were doing it, it's not just feasible to continue to use them. So it was the data growth which resulted in the data science popularity. So as I show here that it's 2018 slide from where I captured this information. That means each day we are generating 2.5 quintillion amount of bytes, which is 10 to the power 18. And it shows that the rate of growth per year is 40%, and 90% in 2018 the data was generated last 2 years. And the reason, another reason for generation of so much data is that there are so many devices connected, interconnected through internet, other means, which are producing data, and that's why that data is getting accumulated. And this data, like we are talking about sensors and all those things, but this main data is like web data generated over the web. There's e-commerce happening, or online banking we are doing, that data is being generated. Similarly, online trading, stock options and all those stocks and all the being traded. So that's also data there. Then there's social network, there's professional networks like LinkedIn, and then there are other network like Facebook and all. So all those things are generating data. So those are adding to the data. So we don't have shortage of data now. We have got too much of data, and we need to use the data to make certain decisions. And that's why we need data sciences. Then I talk about beside the data growth, why is the data growth happen? We talked about devices and all those things connected, 50 billion of them. But how come we can connect so many devices? It's just, how is it possible? And the main reason there is the telecommunication. There's improvement in telecommunication, where bandwidth available to individual in 1990 was 96 kilobits per second. And now individuals can, at home also can have up to 1 gigabits per second access. Mobile, the 5G has the potential of providing 1 gigabits per second on a mobile device. I remember, like in 1990, I was with CMC now, which is part of TCS, working in collaboration with Nick. And we were doing some, in 1991 in Lucknow, we were trying to need to provide from the State Election Commission data of the election results to the Central Election Commission, and we were using dial-up connectivity, and that the speed was 9.6 kilobits per second. And now I don't think people now can imagine working at that speed. It's just not possible. So it's bandwidth availability is one. Then we went to the growth of internet traffic. It's so much traffic is going along. It's 1984, if you can imagine, the total global internet traffic was 15 gigabytes per month. And now in 2014, this is the average per user uses per month. So much of traffic. Traffic means so much data is flowing. It may not be useful data, but it is flowing. There is data there. Then the number of users, so many users, 200 in 2000, 304 million. Now they're 4.6 billion. Like that's an estimate for 2020. And mobile users, smartphone users with internet connectivity and all, there's so many of them, like 4 billion in 2020. Then other thing is processing. Like we got CPUs in 2000, we got 450 megahertz. Now we are talking about 5 gigahertz. And this is the average speed at a home PC. That means people are owning those high, like relatively high compared to 2000, 5 gigahertz CPUs in their machines, PCs. Then average PC hard drive to store the data in 2000, 10 gigabytes. Now average around is 1 terabyte. So it's so much of computing resources, bandwidth, and all those things are helping for the growth. And now cloud computing is just really very critical for data sciences, and it really provides unlimited. There's nothing unlimited, but it has got, because of on-demand resources, we have access to computing resource and storage resource. And so cloud is opened up how we can use the data science and make better use of it. And now we talk about the 4 V's of big data, and just wanted to present the background with respect to data science. So 4 V's are the volume, and for the big data, they talk about data which is more than 1 terabyte, and there's no upper limit how much data we are dealing with when we talk about big data. So volume is 1. Velocity is the speed in which the data is being generated, which has to be examined, and based on that examined process, and based on the decisions has to be made. So the velocity is very important, is one of the factors to say that it's a big data. And by velocity, it could be anything kilobytes, 30 kilobytes or more. It could be a high velocity, which can classify a data as big data. Then there is variety of data. Earlier on, we were talking about structured data, where it was in a tabular form, relational database structure and all, and we call it structured. But now, so much variety, unstructured data is there. That means there are images, they are in JSON files, XML, and all those. Those are still structured, but still there are a lot of varieties now of the data. And that's another factor, another V for big data. Then veracity is another one, like how trustworthiness is of the data is there. And sometimes there are biases of the person producing the data. So when you are looking at that type of data, as part of the cleaning, you need to ensure that your biases or inconsistency, abnormalities, all the duplications kind of thing, the data has been done cleaning, so as we are using a clean data to make inferences from it. So these are the 4 V's of big data. So now we'll go to what is data science. Why data science we talked about, and when we were talking about why data science, we said there's a lot of data growth. There's so much data to be analyzed, so we need data science. So we'll talk about what is data science here in this the next topic, in this next section. Like I believe in that everything is even if there's an innovation, it's evolutionary. It's not that suddenly revolution came, or we decided, there's data science now. Nothing happens like that. Similarly, when we came up with object-oriented design and languages and all, they came from the procedural languages, and we were able to do certain things in the procedural languages, which makes it easier to program it. But object-oriented forced us to present the data encapsulation and the function in one place in a class, so that we evolved in that. Similarly, data science is again an incremental thing, and this will, you will be clear from this timeline, and really, if you look at it, we can say the story of data science is really a story which couples a mature discipline of statistics with a very young one, computer science. So it uses statistics concepts, but computer science helps it to do it better and faster. So like the concept, I started with 1962 from the timeline. It was John Tukey. He was a mathematician. He worked at Bell Labs. It was again more telecommunication related field which the Bell Labs used to work in. And he invented the term, he was the person who invented the term bit, which is, we know, is really the fundamental for the computers. And that he did it in 1947. But later on in 1962, he wrote a paper called The Future of Data Analysis. And he emphasized in that paper that data analysis is really, data analysis is more statistics, which is exploratory data analysis. And compared to confirmatory data analysis, which statisticians used to do earlier, where they used to have a hypothesis first, and from that hypothesis, they used to use the data to determine whether that hypothesis is true or false. But he said that we should be placing emphasis on using the data to suggest an hypothesis to test. That means from the data itself, you come up with an hypothesis so that, and then you can test it. So it's like a different way of thinking, which was not happening before. So that's what his starting part was. And it makes sense now, because with a lot of data available now, it may sometimes be important to explore the data, look at the data, analyze the data, and from there see what are the possible inferences we can make. And once we have those hypotheses, we can test them. So that's what 1962, The Future of Data Analysis, talked about. And then in 1977, there was an International Association of Statistical Computing was established, which was a branch of, or a section of ISI, which is International Statistical Institution. And their mission was to link traditional statistics methodologies with the modern computer technology. And that was to convert the data into information and knowledge. So their mission was that, and that's so that they started using statistics with the computing to come up with, to convert the data into information. So that's another evolution of statistics and computing being combined together. Then we had IFCS. It's another international, called International Federation of Classification Societies, which had in 1996 a conference where they named the conference as Data Science Classification and Related Methods. So data science, just as a word, started to come up at the time. And then 2003, their Journal for Data Sciences was established, and their motto, or they were talking about everything that has something to do with data. They were talking in that, and they talk about and discuss present papers in that journal. Then in 2009, I think that's everybody must have heard about this quote, Hal Varian, in 2009. He was the chief economist at Google, and he said the sexy job in the next 10 years will be statistician. And what he meant really was that with that, and he described more when he had this conversation with McKinsey Quarterly, there's a Maxine, and he said that ability to take data, to be able to understand it, to process it, and to extract value from it, and then visualize it and present it and communicate to the senior management or to the industry and all. So that's what he meant with statistician, that will be in the next 10 years. But basically, it's like combining these things together to come up with like computing science and statistics. And that's what I wanted to highlight here. That's how it evolved, how the data science came into being. So, from data analysis to data science is I meant here is that data analysis has been being done before also. It isn't new, but what is new is that there's vast quantity of data to be analyzed. So for vast quantity of data to be analyzed and the reasons behind all the data growth, where we talk about telecommunication, computing, storage, and all those things, all that thing being available make it possible that we can now analyze that data efficiently. So more data is available than ever, and so is the computing power needed to analyze that big data. So we use the computing power, and that makes it possible to analyze and reveal new patterns and knowledge from the data. So to summarize and to say like what data science does, it helps organization to understand from the data which they have already their environment, analyze existing issues, and reveal some strategies which they were not able to determine concretely because of lack of data or the analysis of data. That means that's what data science does. It helps organization understand their environments, analyze existing issues, and reveal previously hidden opportunities. Then other thing which I wanted to bring was data science and data engineering. I'm talking about it here because in academics, they're very clearly defined. And data science is the computational science of extracting meaningful insight from raw data and then effectively communicating those insights to generate value. So that means the raw data is available, and then we are using the data to come up with some insights. But the most important part is that it has to be effectively communicated so that they are accepted by the people who are deciding whether those strategies or those recommendations have to be followed, as well as to those people on the operational side who will be implementing it. So it involves extracting insights and communicating effectively, data science. But data engineering, on the other hand, is a domain that is dedicated to building and maintaining systems to overcome the bottlenecks which are associated with handling such large amount of data, because there's large volume of data, there's different type of data, how to really combine them, relate them, all those things, that varieties and velocities are handled by the data in data engineering. I just want to point out that even though these definitions there are two distinct definitions, there's a distinction between the two professions, but in industry there is an overlap where each one is doing other professions' tasks, because it's not very clear. Like as a data science person, you may have to work on these aspects so that you are making sure the data is collected properly and you are able to access it, you store it, data warehouse it, and all those things. Those are still being done by the data scientist. So, though very clearly defined, but there is definitely, it's not very, it's in the industry, people are still sharing those responsibilities. So here again, we talk about what is data science. It's manages, manipulates, extracts, and interprets knowledge from tremendous amount of data. It's that we have already discussed, but the other point which we want to bring here is a multidisciplinary field of study, and that multidisciplinary field is required to address the challenges with the big data. And by big data, we have talked about 4 V's of big data, and those, each one of them provide a challenge of how effectively we can utilize the data and to make some inferences or decisions from it. Then, though we talk about big data, but all the principles which for data sciences can be used for a small amount of data or big data also. So it's like universal that way. And the various disciplines, when we talk about multidisciplinary, we talk about the disciplines of computer science, and those are pattern recognition, which is that looking at the data, you can see there are certain patterns, which means the data can be handled in a similar way because it follows a certain pattern. So pattern recognition is important. Visualization is more about presenting your data as well as using the data. When you visualize it, you are able to see the patterns easily also. So visualization is also very important to be able to help understand the data. Then data warehousing is how do you store a data efficiently so that that storage can be used in some in further processing. So there are different types of data warehousing techniques, like or different schema kind of thing, like we talk about dimensional modeling for data marts and all. So those things have to be considered. Then there's high performance computing, where how to process faster. Then there is databases and AI, all those, that knowledge is required for a data scientist. Then mathematics, we have talked about the modeling part is needed to model or come up with a model to analyze the data. And then statistics is different types of statistics concept. Some are deterministic models in statistics, and then there's stochastic modeling, which are like more probabilistic models. Those parts have that knowledge, at least at some understanding of those things are required for data scientists. So here is another picture which I've taken from the literature, is to demonstrate that the multiple disciplines which you have talked about, which is in the center, and then surrounding that is the fundamental skills which are required by the data scientist. So these fundamental skills are necessary so that a better so when you're looking at the data, you can make better conclusions and better recommendations. So you need to have domain knowledge of the subject you are looking at. Suppose you are looking at some healthcare site. So you should have certain knowledge, and that domain knowledge, there may be other SMEs, subject matter experts who can help in it. But by the time you come up with a model, you should have enough domain knowledge so that your model is able to handle the questions you want to answer. So domain knowledge should be there. Then communication is working with your clients, or working with your the subject, or you want to, like, the organization for whom you are trying to resolve a problem or identify a solution. You should be able to communicate with them both orally to understand their needs, as well as in written communication. Then whatever you are come up with, you should be able to present it. So presentation skills are required. Inquisitiveness is basically trying to ask questions. When you're looking something, you are trying to see why, and asking those questions is very important for in data science. And then problem solving, like you should have that a way of how to tackle, how you want to define the problem, the steps you want to follow, and all those things. Problem solving skills is very critical as well. Then business analysis is really how you analyze the business, how you understand your different stakeholders, and what are their responsibilities, accountabilities, and all those things, so that you have a bigger picture and are tackling the right problem. And then from there, after all those things, the result is a business strategy, which comes from the recommendation you're providing based on the data you're looked at. So this Venn diagram, which overlaps so many things, shows data science in the center, which shows that all these things which we talked on the previous slide, visualization, pattern recognition, machine learning, like data mining, and all database related stuff, are all required for data science. But the main thing is that there are so many things, it's so vast. Beside the fundamental skills which are outside, if you've got few of the other skills, like if you have machine learning and database and data processing, so few of them can help for you to be successful in data science. So it's so vast that you cannot have all the things, but you should have the outside fundamental skills, that you are inquisitive and have a knack for problem solving. That is a must. So another picture is just not so busy as we talked about in the previous slide, but it's communicating the same thing, that data science is multidisciplinary, and all of these things together form data science. And here it shows the data engineering also, because there are certain aspects of data engineering which are prerequisite, and sometimes in data science those things are included. Then we talked about scientific method also. It's like how you define a problem, how you collect and leverage data to come up with an answer. Like, it's a scientific method of doing it, so that you don't miss certain parts. That means you're following a well-defined process of doing stuff. And then there's maths and statistics, and domain expertise is for sure, because by the time to come to a model, you have to have the domain expertise, or somebody who is working so closely with you that you can come up with a correct model which will provide the right results. So here we talked about like we have talked about all those things, but different multidisciplinary and all. But here we give a summary of it, that what are the pillars. Business and domain is a must to have expertise in data science. So you may be a data scientist in health, data science in financial, data science in justice, or anything. So, but you are a business or domain expert of that area. So it's you have certain principles of data science, but you are applying in that area. So you will be data scientist in that domain because it's required that knowledge. Then mathematics, which can be used in different domains. And then computer science, you have to have understanding of the software. And now with all these libraries which are there for doing statistical computing and all, you still have to understand those areas. And communication, both written and verbal, is a must. So briefly, if you can define briefly, simply, that's what data science is. That what are the main pillars required to be an expert in data science. And so these are the 4 pillars. As I mentioned, business is something, or domain is something, could be data scientist in one domain. It's not necessary, it's not possible really to be a data scientist in all the domains because it's required a lot of experience in all those things. You can learn it over time, but for a certain period, you will be a domain data scientist in particular domain, and then after you can change the domain, but it's very, very a must for data science. Then in this slide, I alluded to it before, but here talks about a data science lifecycle where talks about capturing, maintaining, processing, analyzing, and communicating those steps. And in the capture, we are talking about how the data is being captured, which is we have to have the data first to be able to use it to come up with certain decisions. So to capture it, data acquisition, maybe somebody already has the data. There is an institution which has been collecting data, maybe a government organization or something which already has the data, and you acquire the data from them, which may be demographic data and all those things. So you acquire the data. Or maybe that is data entry, which you have certain application or something which collects the data and data entry is being done. Signal reception is something where there are sensors and all, and from there the information is coming in through signals, and you are able to get the data. You are capturing the data that way. Then there is data extraction in the sense that in many organizations there are different system, different application, and each one of them is a silo, is separate. So, but you think there is a relationship between the data, so you can data extract it. So that you can extract data from different databases, and also data extraction is there. Followed by, once the data is available, you have to maintain the data so that it is available for usage for processing. So important things there is that data cleaning. As I mentioned before, some of the data which you got may have missing certain values. So you may come up with certain algorithm by which say, okay, the missing values can be replaced by this, maybe average of certain things or some other way. So you can come up with some data cleaning mechanism. Or you can have a data architecture the way you want to store the data so that it is easier for processing. So those things are in the maintain step of the data science lifecycle. Followed with then comes, after maintaining comes the process part, where we are looking at the data and trying to understand more about the data by saying, oh, this clustering is something which says, oh, this data looks similar, so it is of this type. And that way is also the classification, type A data, type B data, and all those things. And data mining is looking deeper into it and finding certain some patterns or something in there. Or in certain cases, we can say, oh, we can aggregate this data, and that data aggregation will be useful in our analysis. So data summarization is something which it can be done as part of this processes in the process phase. Then followed by then is the analyze. In the analyze phase is basically more about coming up with some model, or coming up with certain exploring the data further to help in making some results. Like it can lead to better results. So this is in the analysis phase. And example here is regression. We can take the data and then say, okay, we can apply a regression model to it. And during the analyze phase is that a model can be created with all the parameters, and it will define how the regression equation, for example, or regression the model will be. So that's what is happening in the analyze phase. And followed by analyze is the communication. That means you analyze the data, you have certain results, but now you have to report on the data, and you come up with a decision tree. So that's one way of doing it. And or some classify the data that these are like 50% fall in this category, 25% in this category. So you are making a pie chart kind of thing. So those kind of information comes in the communication. And based on that information, you can come up with certain decisions also. And that decisions can be communicated based on the model results which you got. So these are the 5, and we'll talk about later about this also in terms of data scientists, what data scientists do. But here are the different data science life cycle steps. So how has data science impacted the various industries? We know that data science became popular and emerged in the technology, and it was started with the Google search ranking. Whenever you do a Google search, is able to rank the results in a certain order, and they have an algorithm by which they knew the algorithm was whoever referenced, whatever was referenced the most was shown on the top. So to do that, they have to analyze big set of data. So they came up with different programming methodologies and processing methods so that ranking can be done. Similarly, LinkedIn job recommendation, LinkedIn based on your profile, LinkedIn profile, they send you recommendation of what jobs may fit you. Similarly, Netflix has got it's quite common in North America here, Netflix, where there's movie recommendations based on what you have previously viewed, that they provide recommendation of what you should be watching, what you could watch. And it seems that Netflix is I think it's a very high percentage of people follow Netflix recommendations. So that's from technology, but what we now know that data science is having impact on other sectors also, like retail, telecommunication, agriculture to health, trucking, and in penal systems also, where they have determined if somebody has to, someone has to be released on a bail or something, they can look at the person's profile and recommend whether the person is a risk of flight risk or those kind of risks. So those things are being used, concepts of data science are being used in penal system, for example, also. Then other industries, examples are healthcare. In drug discovery, it is being used. For example, based on the vast amount of data of different drugs and their side effects, a new drug with certain slight different molecule, they can see will there be a reaction of this drug with other ones. So these kind of things that in healthcare it is used for drug discovery, data science. Then travel and tourism also, it has been as we heard, like Uber and all, they do surge pricing and all, because they look at the supply, they look at the demand, and based on that they do that dynamic pricing. Similarly, in hotel business also, they do different pricing. In many cases, you have seen even if you're using different devices also, you are using a mobile device, or if you're using a desktop, sometimes the prices are different as well. Financial services, fraud detection. If you're using a credit card and if you somehow used at a store which you have now used, or an online site which you have not used before, the credit card company can send you an email, is this a valid transaction you did? So the fraud detection is happening using data sciences. Similarly, resource maintenance, schedule, and operation based on the future need of machinery. They can say, okay, maintenance schedule should be done now, because based on the historical data, we know that the machine will be very busy, there will be a lot of demand, so let's schedule the maintenance now. So those things are being used, data science is being used in various ways in all these industries. So now you knew about at a high level what are the skills, like computer skills, statistics skills, and then the fundamental skills like about business analysis, about communication and all those things we talked about. But here we talked more about technical skills which are used and useful and don't require all of it, but you have to have certain knowledge, definitely R or Python, which are these interpreted high-level languages which are being used to create different models in data science for analysis purposes and for modeling purposes. Then Apache Hadoop is really maybe the data engineering. There is a person who will make sure that the system is established for processing, but in many cases, you may have to have the knowledge or may require to do it hands-on for distributed processing of large data system. Understood. Then there's MapReduce, which is a programming model which makes it easier to do parallel distributed processing. Then Apache Spark is more for real time, because it's Apache Hadoop is more like disk is used for it, but for Apache Spark is more in memory, which makes it faster to do processing of big data. So same concept, but slightly different and used for different types of application or purpose. Then databases, NoSQL databases, because we are just not dealing in data science with tabular relational database. So that knowledge is useful. Cloud computing really is, if you look at it, distributed processing and cloud computing part, there's an overlap there, but cloud computing on-demand availability of computer science resources helps, and that knowledge and skill is required because it really is helping us to do the processing faster, and which is required for big data. Then D3 is JavaScript library for producing these visualization, interactive data visualization on the browser. So this is something which is useful to be aware of, and in many cases you may have to use it. Then Apache Pig is a platform for analyzing large data sets. Tableau is another Analytical tool, which is very useful and user-friendly for data visualization. Then Jupyter Notebook is it's a computational environment which helps to do like code executions, as well as you can do mathematical work, plots, and those things you can do it. And then GitHub is really code for code sharing and collaboration tool for and used for the development work. So we move from like why, what data science is, what skills are required for a data, both technical and others. Then we talk about what data scientists do. And here in this case, we'll talk about an example of a data collection application, which is a simple application, but we just understand how the data is collected and how then it is used. So what data scientists do is they perform analytics, like they analyze, come up with the results from that analysis. They also build machine learning pipelines. And by machine learning pipelines, we mean is that there is a collection, data cleaning, then determining what features are there, and then coming up with validating a model, and then come up with a validated model, and then the results, which all that machine learning pipeline, and then they understand their business and customers to make better data decisions. So data scientists do all that. But this is like more machine learning pipelines and make better decisions for the business and all is good. But mostly like 80% of the time, mostly data scientists are working on data collection and data cleaning. And they are building dashboards and reports. And they are more static kind of thing where it is, you have a data, you present the data in certain way, which makes certain things obvious, but it is not something you are learning, which machine learning provides. So most of the time right now, at present, data scientists are doing this work. So the skills data scientist needs are evolving, and but main thing remains is that they should be able to communicate results from the work they have done very clearly. And second work is that they should be able to change very quickly, because as we see, a lot of advances are being made, and there are new tools are coming, new libraries are coming, which can be used, for example, for machine learning example, or for analysis purposes. So that inquisitive mind to understand the problem and solve a problem is also required to be able to make use of new tools, because those tools may save a lot of your data scientist time and may be more efficient and faster. So that is also another basic skill which is needed by a data scientist. Okay, I think there is again, we call it type A and type B of data scientist. And type A is more like, basically they are more about looking at it's more like static analysis they are doing. That means they are able to code and be able to make come up with a model and make some inferences from the model, and that can be used to make a a decision or to come up with a business strategy. So it's quite it's more take the existing data and come up with certain conclusion, more traditional kind of work which was happening before. But now the builder one is they are very strong in coders and they are trained software engineers, so they are not afraid in coding or coming up with a new model, but they are more interested in using the data live and making inferences, which may be more to do with like you have trained a model, like in machine learning terms, you have trained a model and you are feeding into that model new data, and you can spit out the recommendation or what the result is. So that's what it means in production. They are mainly interested in using in production because they are quite comfortable with the solutions which they have developed, that it can be used live in production. So that's the difference between A and B. That means one is more stronger in statistics, and the second type B has the background knowledge, but more stronger in the coding part. So then 3 areas in which this specialization is used is the business intelligence. That means you conclude something from the data, which can be used for business to decide on what the business should do next. Basically looking at the market, and from the market you can see where the market is going. So from that data which you capture from the market, you can make, where should the business be moving next. Decision science, making decisions based on the future course of action. You are based on the data, you are making decisions. Machine learning is other area where you can train your system to help you learn this. The system machine is able to make intelligent decisions based on the experience it has gained over time. So machine learning is other one. So the next one is what data scientists do, how they solve a problem. And we talked about data science lifecycle, and it is really a parallel to the data science lifecycle, where it's referred to as awesome. It's pronounced different. It is spelled differently, but it's like the way to remember is awesome. Is that we obtain, which is like we were talking about before as capture. We obtain. That means we collect the usable data, which is needed to come up with, which is required to come up with some prediction or to make a decision. So you obtain the data first. Following that, you scrub, means you clean up the data, and it's that you are able to remove the biases, duplications, all that in the scrubbing data, so that you are using a clean data to explore next. That means you visualize the data, find out what type of data it is, so that exploration will help you to determine which model to use that can be used for making help in interpretation of the data. So the next step after the model is to interpret the data, and that interpret is used to really come up with a decision or recommendation, or like for the next for the organization to move forward. So it's helping. It has interpreted from the using the model to come up with a next next step. So here I will talk about machine learning definition, and this definition is really simple, but it is includes it covers every aspect of what machine learning does, and if anything fits in this definition, you can say it is a machine learning model or machine learning algorithm. So it is from Tom Mitchell. He's professor from CMU, Carnegie Mellon University, and he provides definition is a computer program is said to learn from experience E with respect to some class of task T and performance measure P. So we have got experience.
Hey.
Hello? Experience E, task T, and performance measure P. If its performance at tasks in T as measured by P improves with experience E. So that means there's a task to be done, and there is a measurement of how well it is doing it. And what we are saying is that performance for doing the task should improve with experience. So if we are improving, which is basically learning, and without us doing extra work for it, like extra coding and all, as the machine can do it by itself, the algorithm can do it by itself, then some machine learning algorithm. So I mentioned here experience E is example is from the training data set. The person the system learns, the algorithm learns from the training data set how the model should be. The model gets updated based on is like trained from those training data sets. Then task T is what decisions to be made. Suppose you have to say like whether what category it belongs to, certain things, and that's what the decision is to be made. That's the task. And performance P is it accuracy you want, that the performance is improving? That means you are able to accurately categorize certain things is improving, that's accuracy. Or your goal was to make it faster, that it is able to come up to the result faster, and that was our performance criteria. Then then accuracy, then the speed may be one of the performance criteria. So that's a machine learning definition. So I moved data science, analytics, and all those things. Now data science include machine learning, and here we started talking about what machine learning is and what's the definition. So next is just so that it's very clear, just to understand the previous definition, because it's so important to have a clear definition. So this is there's a program, there's an email program which watches which email you do or do not mark as spam, and based on that learns how to better filter spam. So this is what the algorithm or the machine learning thing, in this case, machine learning example is doing. And we need to know what is the task here in this case. So if you look at it, the task here is from this explanation is classifying emails as spam or not spam is the task. And what is the experience in this? And experience here is watching labels, watching you, like you are using your email and you say this is spam, that observation, what the user is marking certain things as spam or not spam, is the experience of the algorithm, because the algorithm is noting how one email was marked as spam and all. So, and similarly, performance is one other. Performance will be how correctly the classification is done into spam or not spam is the performance in this case, in this example. You want to make sure that they've been classified correctly is a performance measurement here. So if you look at the previous definition, like for machine learning, a clear definition, you can classify something as machine learning only if it's the performance of the task in T, whatever you defined the task to be, as measured by P, whatever your criteria was, improves with experience. That means it's improving automatically the way you have constructed your model. So type of machine learning algorithms. We talked about, like I'm talking about here, supervised learning and unsupervised learning. They are the main ones. And supervised learning is the right answer. In supervised learning, supervising means that somebody's already telling you that in the training example itself, you have been told the right answer. What is the right answer for a question? Like in the last example, we have given whether the email is spam or not. From the training set, we already defined that which email is spam, which is not. So our answer was given. So for supervised learning, that's a requirement. Then regression predicts. When you have regression, it is a continuous value output. That means the value is continuous. It's not like any value from 0 to 100, for example. It's like any value could be there. Then classification predicts is discrete value. It says that the value is yes, true or false, kind of thing. So I gave an example. A continuous value is employee satisfaction rating, like it could be 4.9, 4.3, and employee salary is a relationship between the two. So you can look at the data, you can have a survey results, and you say employee satisfaction rating and employee salary, how are they, and based on that, come up with a model, and from that model, you can determine in the future what the salary is needed for the employee satisfaction to be higher. There may be other factors also, but I'm giving a very simple example of these two, one very dependent variable, which is the salary. Here, then discrete value is cancer, malignant, or benign. That means you're making a decision based on the tumor size. So it's a discrete value, yes or true or false, malign or not malign, malign or benign. So that's a discrete value example. The unsupervised learning is here, the results are not given, but you look at the data and find patterns from it and then say, how are they related together? So you put them, K-means is a way by which it can determine where is the mean lowest, and that group can form one cluster and the other one can form another cluster. So that is, you were not defined how many clusters were there, or it didn't define how to specify the cluster, but the algorithm can do it and create the clusters. And that is used in like social network data to determine group of friends. So you must have seen in Facebook where they say that a suggestion for a friend. So those kind of machine learning algorithms are used there to provide that information. Then, okay, I provided a very simple case of supervised learning. And here we are using a linear regression model where our there are a number of features, and I gave a simple example of determining final, like you have been determining how much you will get, what will be your final grade, and your features are that you are saying assignment number 1, how many marks you got, assignment number 2, how many marks you got, quiz number 1, midterm marks, you have got that data, and you want to predict what will be the final grade. And basically, the training records in this case will be the previous year data. You are using, basically, that means you know the results based on the assignments marks obtained, the quiz marks obtained, the midterm marks obtained, what was the final grade given by a certain professor. So that information is there, and now you are predicting how much will the final grade be for somebody as a new student. For example, a student wants to know it based on this, because final grade will include the final exam also in it, but final exam marks are not known, but based on the historical data of how hard the final exam is generally created and how well, based on your knowledge you have from your assignment marks and all, you can know what knowledge the person has gained, so how well the person will go and do in the final exam. So those factors are there. So here is the number of features, and in this example, and then there is number of training records which will be used to create a model, and then there's input features for the training example, and then there is features J. These are notation which have been put in the training example, what our value of the features are. In this case, value of the features will be the marks of assignment number 1, marks of assignment number 2. Those are the values of features. Then output value of the ith training example here in this case is the final grade. So that's how output of the ith training example is. Then hypothesis function is the final grade. Final grade is dependent on these other, on the different features, and how much is the weightage of each of the feature, which is represented by theta, theta 1, theta 2, and theta 3. So what they're trying here in this regression function is they create a cost function, j theta they call it, and it is, if you look at it, they are trying to find out the square of the difference between what the model predicts and what the actual value is. And the model predicts are the values, what the model predicts is the value the model is giving, and the y value is what the actual value was. And what you have to do is, for the regression to be accurate, is to have the cost function as low as possible. And to do that, they came up with this gradient descent. It's not shown properly. Just gradient descent is the way by which they doing this learning, through which they are able to determine the values of thetas. And if you have, and basically this formula can be derived from the calculus, where you talk about the minimum of a surface, and you differentiate it, and that differentiation will give you the value of how closely it is moving towards the lowest point. So here you put those values, you try to get with each training example you are using, you are coming with better theta values, and those theta values you put it into the j theta to find out how low it has gone. And that once the theta values we have found the lowest point, then from the training examples you can put it in the in the hypothesis equation, and that will be your regression equation. And that way, what you've done, you have come up with a model based on the training examples you had, and that model can be used for predicting a newer record for which you don't have a final grade. So most of the time what's happening, this is like a static kind of thing, and the data could be millions of records in a real life example. So what generally data scientists do in this case is they train the model in advance. They are not dynamically training it because that requires a lot of processing and all those things. So they can come up with a model, and that model is running in production. And then later on, they said, oh, we have collected more data now. Let's train the model again. They do it offline, and they train the model, come up with a new model, and then they put that model into production. And that new, better model is then used for predicting. So the training, the learning, and all those things happening offline. So that's how it is used. In certain cases, with increase in processing and all those things, we can do a different, more real-time thing also. But most of the time, in majority of the cases, a model is trained offline, and then it is put into production for usage. So this is like a very quick showing that using the training examples, you are able to come up with a better model, and the better model is the more accurate values of thetas. Okay, here I give an example of very quickly here that the data collection is done. Once the data collection is done, it has to be used to do some outlier analysis, variance analysis, generating reports, and all those things. So the example here is for public institutions like universities and colleges, which are funded by government. Here's an example in province of Alberta here in Canada, where this information is being collected, and which is like the programs, which programs are offered by institutions, what courses are offered in those programs, what agreements is like, how if somebody wants to transfer from one university to another, what are the agreements, what courses can be recognized by the other university. So students information, who are enrolled in which programs, applications, which programs, for which programs the application was submitted. And enrollment is where you enroll. Financials, that means how much was your expenses, how much was the revenue, and funding. Because these are government funded institutions, depending upon how much is the enrollment and those things, the funding is provided. So all that information, the enrollment program, enrollment information, program information, all this thing is needed because for the funding purposes. Then sessions is like whether you offer this program in the winter session, in the fall session, or the spring or summer. So those are session information is also collected. Surveys is like how well the graduate of the program did in the after completing the program, whether they are satisfied with the program, how much was their salary. Those kind of things are collected from surveys, and those surveys are done by a third party but fed into the ministry, so that the ministry can recognize how well the institutions are doing with respect to their programs they are offering. Then transfers, like how many, like there was agreements to see where you can transfer, but transfers are who transferred from which institution for which program and all, so that you know which program is more popular in which institution, because people are transferring from one institution to another. So all the data is collected, and there are different applications which are collecting this information. I'm just putting that into one big big basket that this data is being collected. And to collect the data, the users have to be authenticated and authorized, whether they have access to submitting the programs data, for example. So authenticated then is their valid user, whether they are authorized to submit the programs data is being done. So all this information, and when they submit the data, the data is being validated also at the same time, so that the cleaning part is happening at the time of entry or the data submission. And the data can be submitted in different formats like CSV, whether it's Excel, XML, and future we are talking about at present the institution user is submitting, and we are talking about machine-to-machine data submission through web APIs and all those things that they can submit the data. And once the data has been validated and all, it has to be by ministry has to do the approval also, that data submitted makes sense, it's approved, then the data goes, submitted data is in the operational database, it's put in the operational database, and then from the operational database, the SSRS reports, Microsoft SSRS reports are generated, which the user can see, which could be ministry user or institution user. So this is, and then I'm showing other DBs, other databases are being used so that the validation of the data which is being submitted can be done, because not all the information, you submit some student information, but the student was there last year also. So whether that student information is accurate or not, like their student ID, their gender, date of birth, was it correct? The other database had that information, but you are validating that that information submitted this year matches with that user, because first name, last name, and all those things. So this is database is coming. From the database, the ETL is done and is stored in this database to do to help in the validation for the application which is collecting the data. So this is data collection, validation, and some reporting, which is the operational reporting. It's shown here. Then the other part we are doing here is that from the operational data, the data is operational data representing so many applications, which is collecting this information across the province, is then ETL'd, and this is done periodically. And in our case, because large amount of data is there, it is done nightly. And it moved from operational, which has got the current year data only, and some data which is required for validation is moved into data mart, which contains all the historical data. So the data mart has got all the historical data that, and it's a dimensional model, which is it's constructed in fact and dimension tables, and from there, from the data mart, the users can use OLAP for making able to see in different way the data, then SSRS reports from there, and then analytics in there where they can do variance analysis. How many, in this institution had only 100 enrollment, for example, or 100,000 enrollment, and this year they got 200,000. Why so much variance? So those kind of variance information can be obtained here. And then SPSS is again for further analysis and for plotting information. So this was so at present it looks very static, and that's what is being done, like data collection, cleaning, and reporting, visualizing, and all those things are happening. But in future, we are looking to enhance this thing so that we can use some machine learning information which can predict how much will be the enrollment based on the historical information, for example, and how much funding will be required for that, so that accordingly the budgets could be created. So those certain things which we are looking at for the future, but at present it looks very static at this time. So to conclude is that data science can help organizations understand their environment, like they can analyze existing issues and reveal previous hidden opportunities. So as I've repeated this number of times, that it's because so much amount of data is there, it is hard to analyze with data. So data sciences algorithms or skills are required so that we can come up with better recommendations or analysis results. And this is possible because data is there, but so there's increased data, but we have got also improved algorithms so that it makes it easier and faster to do it, as well as we got the computing resources to be able to do analysis faster. And data collection, data cleaning are the main things which data scientists are doing. But as we are moving further and further towards more machine learning, that it's becoming more mainstream. That means we in industries, we are in education sector, like I'm doing consulting work in education sector. We are already starting thinking of using machine learning in that area, in the domain also. So other thing which I repeated earlier is data scientist and data science is multidisciplinary. So you should, data scientists should have advanced knowledge and technical skills and mostly computer science, but a background in statistics and mathematics is required so that you make the right choices in the model or the APIs or the libraries, type of library you are using. As well, it will help you with this statistics background is what type of model, whether it should be a classification model, whether it should be a regression model, and all those things. So all these, like it has to be treated as a multidisciplinary thing, and with knowledge of statistics is very much needed. So that's conclude what I had to present, and I hope I was able to communicate to you what data science is, the different aspects of data science, and what in industry is happening right now, and how industry will be moving towards more things which we are talking in academics or in certain high-profile cases like self-driving cars, or those kind of things of uses of machine learning is also happening in industry as well. So if I can take your questions, and if you have got some questions, I can try to answer those and provide my views on that.
Students, if you have any query related to the fundamentals or the theoretical aspects of data sciences, you are most welcome to ask. You can unmute yourself or you can write in the chat box.
Hello.
Hi. Hello,
Yes,
yeah.
sir, how data science and machine learning is correlated to each other?
Okay. So machine learning is also a way by which you are able to interpret the data, but what machine learning adds is that is able to learn. That means from the experience, it's able to provide a better result. So machine learning is doing learning with experience, but in other cases, when we do the data analysis itself, it's more static. So they are really doing this. They are related that way because they are data analysis, and data science involves data analysis, and machine learning is a subset of AI, which is part of the data science.
Okay. Thank you, sir.
Any more questions?
Sir, I have a question.
Yeah.
As you have explained that, stressed on this point that most of the data scientists are now working mainly on data cleaning and data analysis. Sir, is it and data cleaning and data analysis the data scientists are doing? Are they doing across the globe? They are into this cleaning and analysis part, or you see in India the rising or the potential data scientists that are coming up, they are mostly involved, or the industries which are using or trying to leverage this data science to improve their business are only using it for cleaning and analysis purpose. This is question number one. And question number two, sir, you have categorized this practice into major categories, broad areas. One is related to the business consulting. Basically, they are doing business analytics only, and the other one are the hardcore coders. So, do you think these hardcore coders will have edge on the former, or the requirement of business analytics is different subject to the industry, and they will be serving being in that category only, by being in that category only?
Okay. I think like I'll answer your second question. I personally think that, as I mentioned in that picture where there were a lot of Venn diagrams, and then I was talking about the fundamental skills required, I believe those qualities are very critical to have to become a data scientist. That means data scientists are more like they are able to look at the data, make conclusions, and be able to communicate and give recommendations. But the data engineers, or like hard or data scientists, which fall in the builder category, are more hard coders. They're coding, they're coming up with the models, but they may not be, if they don't have the other skills, they may not be so they may not be able to influence the decisions. And basically the whole purpose of data science there is to influence the senior management or the organization to follow what you think is required or what you feel the organization should go into. So I think both of them are very critical. Both of them have a place there, but data science has become more it's not as much of coding as, because of the libraries and all those things. You don't have to, like, I remember that when I was doing something in the matrices in 1991, I created all the metrics coding in C, and then I use it for this thing. But now there are so many things available. If you've got a high level knowledge of it, you will be able to come up with a model. And once you have a model and a prototype, you can work with the hardcore data scientists who can code very well to come out and improve that model with respect to the performance. So for me, it depends upon the data science, the person who wants to go into data science, which type A or type B they want to be, depending upon their skills and depending upon their interest. So, but I think both of them will be critical. And I have one of my friend who is really working. He's working in Amazon, and he as a senior data scientist. And his emphasis is that it's like they can rely on data engineers to have the performance and all those things, but it's more important to have the background in statistics and some knowledge of coding to come up with a model. So I think, and the other question, what was the first question you asked?
Sir, I was asking that these data scientist community across the globe is restricted to cleaning and mining job? Or...
No, I was talking about 80% of the time that's what is happening, but 20% of the time is people are working on so many, like like you see, like everywhere you go, you will know that, and there's something behind the scenes doing some advanced analytics and predicting, recommending, and all those things. So those things are happening in like high-tech industries, that they are coming up with different models to be used. That was 20%, but 80% right now, and 20% maybe in maybe hundreds of thousands of people who are working in that, the 20%. But the remaining 80%, they are slowly moving towards, as we are planning to do, is moving towards more advanced usage of the data, which will include, for example, machine learning in this. So at present, the way we are doing it, we are using reporting, visualization, variance analysis, all that kind of detailed analysis. But that part has not come. It's becoming mainstream, but it's not mainstream that data scientists are only doing that part right now.
Thank you, sir.
Thank you, sir. Thank you, Mr. Anshuman Tyagi, for a wonderful session. For spending time, I think it must be about 11 or 11:30 night at your location. So thanks for giving time to us and sharing your knowledge about fundamentals of data sciences. And I know, or I'm sure that the participants connected to us must be clear about the prerequisites, and they will be ready for the further hands-on sessions related to this particular FDP. Thank you very much. Thank you, sir.
Thank you very much for inviting, and thanks. Hopefully the presentation was informative, and if you need to contact me, I had my email address, and I can share my email address with the coordinator, Dr. Nidhi. Thank you.
All the participants are requested that they should maintain the 80% attendance during this FDP as per the norms of AICTE. And at the end or the last day, we will be having the tests quiz in form of MCQs, and you're required to score 60% minimum during in that particular quiz. So and also make sure that you are approved on the ATAL portal. Otherwise, the certificate will not be generated for you. So we will be meeting again at about 11:55 or 11:50 for another session. Maybe most probably we will be having a hands-on in that particular session, and other sessions will be much more applicative. And the prerequisites for this particular FDP must be known, or you must all be familiar by this session. Thank you all. Thank you for joining the session. Thank you all.